In Chapter 3, we're going to begin to refine the ideas of center and spread that we saw back in Chapter 2. And this is because when you're comparing two sets of numerical data, it's helpful to have a number that measures center and another number that measures spread. The mean is something you're probably familiar with already. The mean is just the arithmetic average of a set of data. You add all of your data points together and you divide by the total number of data pieces that you have. The mean is one method for measuring the center of our sampling distribution or distribution of a sample. There is another method that we're going to see later on, so the mean is just one method. Remember from Chapter 2, the center is described as the typical value. So if you had to pick one number to describe what's going on, what would you pick? That would be the center. Now, an important thing to note here is that in order to use the mean, the distribution that we have, the graph that we see, needs to be symmetric. That's how we know to use the mean as the measure of center. If the distribution is skewed to the left or skewed to the right, we're not going to use the mean. That's because the mean gets pulled into the tail when the distribution is skewed. And therefore, it's not a typical value. It's not that highest peak anymore. It's somewhere pulled down into the tail if it's skewed left or up into the tail if it's skewed right. Just to visualize this. Recall a skewed right distribution has a tail on the right-hand side. So this right tail is longer than this left tail. This is not symmetric. The mean would not be at this highest peak where you're seeing a lot of observations. The mean might be pulled somewhere up here in this area. And the opposite is true if it's skewed to the left. We would have this tail longer on the left-hand side than the right-hand side, and the mean would not be up here at this highest peak. The mean would be down here where the tail begins. Something that you need to be aware of is that when the distribution is skewed to the right, the mean is always in the upper portion of the data, and when the mean is skewed to the left, the mean is always in that lower portion. The last thing that we want to do here is look at how we can calculate the mean. So in this example, I have the monthly premium for health insurance for 12 families in Florida. You can see it ranges from $393 all the way up to $448. A dot plot indicates a fairly symmetric distribution. There's not a tail on one side or the other, so because this is symmetric, we can feel good about using the mean as our center. We want to know what is the mean for this particular data set. Now you could add all of these together, get that total, and then divide that number by 12. I'm going to show you an alternate way on your calculator that'll help with some future calculations. So on your calculator, the first thing we're going to do is go to this stat section, hit the stat button, and we want to edit. We want to edit our data, so you just hit enter. So I've hit stat and enter. And in L1, I'm going to enter in my 12 numbers. 393, 402, 403, 403, all the way until the end. Now that I have all 12 numbers in, to get my mean, to get that calculation, I go back to the stat menu. I hit the stat button. I hit the right arrow to go over to calc. And what I need is already selected. I want number one var stats. I hit enter until my list populates. Depending on the software your calculator's running, it might take 3 or 4 presses of the enter button, but just hit enter until this pops up. And I see my mean at the very top. That X bar equal to 419, X bar, that is our mean. So I can say for this case, X bar, which is the mean, is $419. On average, these Florida families are paying $419 a month. There are more things in this list, and we'll talk about a few of these in future videos.